For this next part, for graphing our linear equations, we have the equations in what is called standard form. Now, standard form takes the shape of ax plus by equals c. This is not slope-intercept form. It does not give you the slope or the y-intercept of your equation just by looking at it. So when we're trying to graph a line, generally we would like it to be in slope-intercept form. That is the easiest way. But with standard form, it is still possible to graph these lines. There's two ways that we can do it. Way one is to convert it to slope-intercept. Okay, and I'll show you that with one of the final examples. And then the second way is to find the x and y intercepts. Okay, the x-intercept is where the line goes through the x-axis, and the y-intercept is where the line goes through the y-axis. And standard form is really good for finding both of these, the x and the y-intercept. So that's how we're going to start this off, is using this second little point that I put here, finding the x and y intercepts. And then for the last one, because that one isn't going to work as nicely, we'll see how we can convert it to slope-intercept form. So all right, with our first one here, we have 2x plus 4y equals 8. Our goal is to create the line by finding the x and y intercept, which means we're only going to have 2 points. One point that's on the y-axis somewhere, and one point that's on the x-axis somewhere. Now, in order to do this, first I'm going to talk to you about the main idea of how we do this, and then I'll show you the easiest way to do this. So, with how we're doing it, an x and a y-intercept always take the same form. The x-intercept has a number in the x value and a 0 in the y value, okay? Because that tells us we're going over on the x-axis somewhere, but we're not going up or down. And conversely, the y-intercept always has a 0 in the x value and some number in the y position. So that tells us we aren't going left or right, but we are going up or down. So we're going to use that to our advantage. When we are finding these x or y intercepts, we are going to put a 0 in for the variable we're not working with, and then just solve for the one we are. So let's say we've got our 2x plus 4y equals 8, and I want the x-intercept. That would be 2x plus 4 times 0 has to be 8. And what's 4 times 0? That's 0. That's nothing. So this is gone. And I'm just left with 2x equals 8. So now I can solve for x through division, and x is 4. So my x-intercept is at 4, 0. And I can go to my graph and put my first dot at 4, 0 right there. Now I can do the exact same thing for the y value with the y-intercept. In the y-intercepts, the x is 0, so I'm going to have 2 times 0 plus 4y equals 8. Once again, 2 times 0 is 0, so that's gone. I'm left with 4y equals 8. Solve for y, and we get y is 2. So my y-intercept is 0, 2. I don't go over at all, but I go up 2 on the y-axis, and now I have graphed my y-intercept and my x-intercept. Get my straight edge. I only have 2 dots, and that's okay, because all you need is 2 to draw a line. Connect them, and we're good to go. So that's doing all of the work here, where we put in the 0 for the value we're not working on. Like up here, we were trying to get the x-intercept. Down here, we were trying to get the y-intercept. So the value we weren't working with became 0, and we were able to algebraically work it out. But for this next one, I'm going to show you the little shortcut. So we have 3x minus 5y equals 15. Remember that the x-intercept Okay, remember that the x-intercept is going to be something, comma, 0. And the y-intercept is going to be 0, comma, something. Well, since I know that the y value is going to be 0 here, I like to do what I call the cover-up method. And I'm just going to cover up the y. Because if it's 0, it's going away anyway. So I'm just going to look at it as 3x equals 15. Well, what value of x makes that true? 3 times what is 15? And hopefully you're saying 5, and that would be correct. So our x-intercept occurs at 5, comma 0, down here. Now for the y-intercept, I once again can do the cover-up method. I'm just going to cover up the x. Okay, and I don't cover up the operation between them, whether it's positive or negative. Okay, especially if it's negative, because I have a negative 5y, and I want it to become 15. So I can either write this out separately and solve it, or think to myself, negative 5 times what is positive 15? And hopefully you say negative 3. So I'm going to put the dot at negative 3, and now I have my y-intercept and my x-intercept, and I'm ready to draw my line. Oops, and that was not a perfectly drawn line. Whoops, but it gets the point across. All right, now let's take a look at down here. This problem, excuse me, this problem would work with the cover-up method that I just showed you, or finding the x and y intercepts. But if you remember back up here, I said another option is to convert it to slope-intercept form. So that's what we're going to do with the last two examples. This first one right here would work with the cover-up method, but we are going to convert it. And to convert it, that means we want it to look like y equals mx plus b. Basically, we want to get the y all by itself. That's the goal here. That's how we change it to slope-intercept form. So I'm going to write it off to the side here. I have 4x plus 7y equals 28. I'm going to subtract 4x. You always subtract you always subtract the x term from the same side as the y. That's going to get rid of it, and I have 7y equals negative 4x plus 28. You could have also written 28 minus 4x. It's the same thing. And then we're going to divide everything by 7. Everything. So that gets rid of the 7. And you're left with the y by itself equals negative 4/7 x plus 28 divided by 7, which is 4. And this equation right here is exactly the same as this equation right here. It's just that we've changed it around to make it into slope-intercept form. Now we can do like we did in the first video. My slope is negative 4/7, meaning I'm going down 4 and to the right 7. And my y-intercept is 4. So I would put my dot at 4 on the y-axis. And if I were to do the cover-up method here, I would get that as well. 7 times what is 28? 7 times 4. Okay, so now using the slope, we're going down 4 and to the right 7. So down 4 to the right 7, 4, 5, 6, 7, and we'll put our dot here, which just so happens to be our x-intercept. And if I did the cover-up method here, 4 times what is 28? 7. So it confirms the cover-up method works, and it shows that we can do our slope-intercept form approach as well. Now I could do more dots if I wanted to go backwards, but we only need 2, so I am connecting them. All right, and now we're on to our last one. The last one does not work nicely with the cover-up method for both values. Okay, x minus 5y equals 9. And honestly, because of how I wrote this, it's not going to work super nicely with slope-intercept form either, but that's okay. So first of all, let's think about covering up stuff. If I were to cover up the y, I get the x-intercept right away. X is 9. So I know my x-intercept is going to be down here. But covering up the x, negative 5 times what is 9? And that's not a whole number because 9 is not a multiple of 5. So that's where the problem comes in. And if we were to change it in the slope-intercept form, it's not going to fix it either. So we have x minus 5y equals 9. We are going to subtract x from both sides and have negative 5y equals negative x plus 9. And then we're going to divide everything by the negative 5, and that's dividing everything. We end up with y equals negative divided by a negative is positive, so those will be positive, and it'll be 1/5 x, because there's one x on top, minus 9/5. So my slope is 1/5, up 1 to the right 5, and my y-intercept, unfortunately, is negative 9/5, which is not a nice number. Okay, it's a decimal. It's negative 1.8. So we can still graph it. It's just going to have to be an approximation. So negative 1.8 isn't quite at negative 2, so I'm going to say it's right about there. And we got our x-intercept from the cover-up method. We have our approximate y-intercept. I have my 2 points. I can connect them. And there we go. We've got our line. So all right, that's pretty much it for our review on how to graph linear equations. Hopefully this was helpful and you will be more successful starting in chapter 4 where we have to graph a good amount. So hope that helps and good luck.